The answer key to the practice exams found in the electrical exam prep based on the 2002 National Electrical Code is not included within the book itself. The answer key can be purchased independently from Mike Holt Enterprises Incorporated. Electrical codes, such as the National Electrical Code, are updated on a regular basis to reflect the latest safety standards and technological advancements within the electrical industry. These codes are crucial for ensuring the safe installation and operation of electrical systems in residential, commercial, and industrial settings. Changes between code cycles may involve revisions to existing requirements, the introduction of new articles, and the deletion of outdated information. It is essential to understand that using outdated materials for exam preparation can lead to incorrect answers and a misunderstanding of current regulations. When preparing for an electrical exam, firstly, ensure that you are using study materials that are aligned with the current version of the National Electrical Code or the specific code year that the exam is based on. Secondly, determine the specific edition of the National Electrical Code that is referenced by your exam. Thirdly, acquire study materials, practice questions, and resources that are consistent with that code edition. The National Electrical Code, often abbreviated as NEC, is a comprehensive set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is revised every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. The National Electrical Code covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It is designed to protect people and property from electrical hazards such as fire, shock, and electrocution. The National Electrical Code is not itself a law, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Electrical inspectors use the National Electrical Code to evaluate electrical installations and ensure that they meet minimum safety standards. Compliance with the National Electrical Code is essential for ensuring the safe and reliable operation of electrical systems. The National Electrical Code consists of a complex collection of standards and guidelines. Firstly, it's important to have a strong understanding of the code structure. Secondly, each article addresses specific aspects of electrical installations. Thirdly, navigate the code effectively, familiarizing yourself with the table of contents, index, and cross-referencing system. Understanding the code's organization is crucial for efficiently locating relevant information. The National Electrical Code is organized into chapters, articles, parts, and sections. Chapters are the broadest divisions of the code, covering general topics such as wiring methods, equipment, and special occupancies. Articles provide more detailed requirements for specific types of installations or equipment. Parts within articles further refine the requirements, addressing specific aspects of the topic. Sections are the smallest units of the code, containing individual rules or guidelines. The National Electrical Codes Index is an invaluable tool for quickly locating specific information within the code. It provides an alphabetical listing of subjects covered in the National Electrical Code, along with references to the relevant article and section numbers. The index is particularly useful when you are searching for information on a specific topic but are unsure where to find it in the code. The National Electrical Code also uses a cross-referencing system to link related requirements in different parts of the code. Cross-references are indicated by references to specific article and section numbers. For example, a section on grounding may include a cross-reference to a section on bonding, indicating that the two topics are closely related. Using the cross-referencing system can help you gain a more complete understanding of the National Electrical Code's requirements. Overcurrent protection is a critical aspect of electrical safety, designed to protect electrical systems from damage caused by excessive current flow. Overcurrent protective devices, such as fuses and circuit breakers, are designed to interrupt the flow of current when it exceeds a predetermined level, preventing overheating, fire, and equipment damage. The National Electrical Code provides detailed requirements for overcurrent protection, including the selection, installation, and coordination of overcurrent protective devices. Overcurrent protection is essential for preventing electrical hazards and ensuring the safe operation of electrical systems. Grounding is another fundamental aspect of electrical safety, providing a low impedance path for fault current to return to the source. Grounding helps to minimize the risk of electric shock by ensuring that metal parts of electrical equipment are at or near ground potential. The National Electrical Code specifies the requirements for grounding electrical systems, including the types of grounding electrodes, the sizing of grounding conductors, and the bonding of metal parts. Grounding is essential for protecting people from electric shock and ensuring the safe operation of electrical equipment. Wiring methods refer to the different ways in which electrical conductors can be installed and protected. The National Electrical Code recognizes a variety of wiring methods, each with its own set of requirements and limitations. Common wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, cable trays, and flexible cords. The choice of wiring method depends on factors such as the environment, the type of occupancy, and the voltage and current levels. The National Electrical Code provides detailed requirements for each wiring method, ensuring that electrical conductors are properly protected and installed. Special occupancies refer to locations that have unique electrical requirements due to their specific characteristics or uses. The National Electrical Code includes specific requirements for a variety of special occupancies, such as hazardous locations, healthcare facilities, and places of assembly. These requirements address the specific electrical hazards that are present in these occupancies and ensure the safety of people and property. Hazardous locations are areas where flammable gases, vapors, or dust may be present in the air, creating a risk of explosion or fire. The National Electrical Code divides hazardous locations into different classes and divisions based on the type and frequency of the hazard. Each class and division has its own set of requirements for electrical equipment and wiring, designed to minimize the risk of ignition. Healthcare facilities have unique electrical requirements due to the critical nature of the services they provide. The National Electrical Code includes specific requirements for essential electrical systems, which provide backup power to critical equipment in the event of a power outage. These requirements ensure that essential services such as life support and emergency lighting continue to operate during a power outage. Places of assembly, such as theaters, auditoriums, and churches, have specific electrical requirements to ensure the safety of large numbers of people. The National Electrical Code includes requirements for emergency lighting, fire alarm systems, and other safety-related equipment. These requirements help to ensure that occupants can safely evacuate the building in the event of an emergency. Electrical calculations are an essential part of electrical design and installation. Electrical calculations are used to determine the proper size of conductors, overcurrent protective devices, and other electrical equipment. The National Electrical Code provides guidelines and formulas for performing electrical calculations. Accurate electrical calculations are essential for ensuring the safe and reliable operation of electrical systems. Firstly, calculate the load. Secondly, determine conductor ampacity. Thirdly, size of recurrent protection. Fourthly, calculate voltage drop. Fifthly, perform short-circuit calculations. These calculations are essential for ensuring the safe and reliable operation of electrical systems. Load calculations are used to determine the total amount of electrical power that will be used by a building or electrical system. The National Electrical Code provides different methods for calculating loads, depending on the type of occupancy and the types of loads involved. Accurate load calculations are essential for selecting the proper size of service equipment and conductors. Conductor ampacity refers to the maximum amount of current that a conductor can carry safely without overheating. The National Electrical Code provides tables that list the ampacity of different types of conductors based on their size, insulation, and temperature rating. It is important to select conductors with sufficient ampacity to carry the expected load. Overcurrent protection is designed to protect conductors and equipment from damage caused by excessive current flow. The National Electrical Code specifies the maximum size of overcurrent protective devices that can be used to protect different types of conductors and equipment. Voltage drop refers to the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Short-circuit calculations are used to determine the amount of current that will flow during a short-circuit fault. This information is used to select overcurrent protective devices that can safely interrupt the fault current. Grounding and bonding are essential for electrical safety, providing a low impedance path for fault current to return to the source and minimizing the risk of electric shock. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. Firstly, grounding electrodes. Secondly, grounding conductors. Thirdly, bonding jumpers. And fourthly, equipment grounding conductors. These components work together to create a safe and effective grounding system. Grounding electrodes are used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Grounding conductors are used to connect the grounding electrodes to the electrical system. Grounding conductors must be sized according to the requirements of the National Electrical Code. Bonding jumpers are used to connect metal parts of the electrical system together, ensuring that they are all at the same electrical potential. Equipment grounding conductors are used to connect the metal enclosures of electrical equipment to the grounding system. Equipment grounding conductors provide a low impedance path for fault current to return to the source, minimizing the risk of electric shock. Electrical safety is paramount in all electrical work. Adherence to safety practices is essential for preventing electrical accidents and injuries. Firstly, to energize circuits before working on them. Secondly, use appropriate personal protective equipment. Thirdly, inspect tools and equipment before use. Fourthly, follow lockout/tagout procedures. Fifthly, be aware of your surroundings. These safety practices are essential for preventing electrical accidents and injuries. The energizing circuits before working on them is the most important safety precaution. Before working on any electrical circuit, it is essential to turn off the power, the circuit breaker or disconnect switch. Use a voltage tester to verify that the circuit is de-energized before touching any wires or component. Personal protective equipment, or PPE, is designed to protect workers from electrical hazards. Common types of PPE include rubber gloves, safety glasses, and arc-rated clothing. It is important to select the appropriate PPE for the task at hand. Tools and equipment should be inspected before each use to ensure that they are in good working condition. Damaged or defective tools should be removed from service immediately. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve placing a lock and tag on the circuit breaker or disconnect switch to prevent it from being turned on. Awareness of your surroundings is essential for identifying potential hazards. Be aware of the location of overhead power lines, underground cables, and other electrical equipment. The information presented here is for educational purposes only and should not be considered a substitute for professional electrical training or advice. Always consult with a qualified electrician before performing any electrical work. Improper electrical work can be dangerous and can result in serious injury or death.